lesson, I guess. Not like it is a trick, but it's kind of sad, I guess. So we're doing polynomial division. And it is long division, and it is long sometimes. Okay? Bottom line. That's how it goes. Right? So if you don't have the note guide, write down the division problem. If you do have the note guide, you're fine. All right. So long division, we set it up just like a long division problem. The only difference is it's a polynomial. So you also have to be aware of, you know how when you write like 105, you don't just write the 1 and the 5. You put a 0 in the spot where the 10 space is missing a number, right? To account for that the 1 is in the 100 spot. There's nothing in the 10 spot, and then the 5 is in the 1 spot, right? So we fill it in with a 0 if there's nothing there. Our number system would be really weird if we didn't do that, because somebody might mean 105, but it would look like 15 because the 0 wouldn't be there. So we want to take that same idea into polynomials, accounting for each degree of the function to make everything line up properly. So see that this function is a quartic because its highest degree is 4. But if we write it in standard form, which it is written up here, you can see that it does skip a degree. Which term is missing from the quartic? The cubic term. So when I do the division problem, just to make my life a little easier, and you'll see why in a second, I'm going to actually put a quartic or a cubic term in there. What can I add to something that doesn't make any difference? 0. So I'm just going to put 0x to the third. All this is going to allow me to do is allow everything to line up nicely in my polynomial. All right. So this is the same long division process, you know, with a little twist because it's a polynomial function. So first what we're going to do is we're going to look at how many times this goes into this, which is a weird question. So what you do is you generally look at trying to make the first terms match. Okay? You know how when you do the division process, it tends to go off and to the right? Because you're getting rid of the higher placed numbers till you boil it down to like a single digit number left in the problem, like we did in the math moment. We want the same thing to happen here, which means if 2x minus 1 doesn't match up perfectly with what's right here, we at least want it to cancel out the highest degree term so we can boil it down to like a single number, just like we did with long division. So when we make our decision, we're going to look really closely at the first two terms and try to make them match. So what would you multiply 2x by to get 4x to the fourth? Okay, so 2x cubed is what I'm going to try. Now, why would I write it over the second term instead of over the first term? It doesn't matter too much. It's just kind of an organizational thing. Alex? Good. So this is a binomial that you're dividing by. So remember, once you decide what goes up here, what do you do with the number that you put up here? You multiply it times your divisor. So this is 2x cubed times 2x minus 1, two terms. Okay? So 2x cubed times the 2x gives me 4x to the fourth. That's what we wanted, right? Matching first terms. And then 2x cubed times the minus 1 is going to give me minus 2x cubed. Do you guys see why I put the 0x cubed there now? So I have a nice place for things to line up. Otherwise, this would have lined up with this, and if I'm not careful, I could make some stupid mistakes and combine wrong terms. Now, once you multiply them together, what do you do with these two things in the division process? You subtract them. Now, subtracting this, okay, is really like adding the opposite of each term so that the first term cancels out, which is what we wanted because we want to narrow it down to the smallest thing possible. And then I'll finish this part here. So 0x cubed plus 2x cubed is going to give me 2x cubed. And I'm going to drop down the next term just like I dropped down the next digit in a division problem. So do you see how the process is very similar to the long division process that you already know? Okay. All right, so next decision. I now want 2x to be as close as possible or match with 2x cubed. So what am I going to choose as the next term of my quotient up here? think about it, x cubed or x squared? X squared, because it's going to multiply with an x, so it will make x cubed already. So x squared, positive x squared. I don't need to make it cancel out on my own. I need to make it look the same. That way when division problem, the part where we get to when we subtract stuff, it cancels out. Okay? So I choose x squared. X squared times 2x gives me 2x cubed, which is exactly what I wanted. And x squared times minus 1 gives me minus x squared. Okay? And again, I'm subtracting all of this, which really means I'm like adding the opposite of each term. So those first terms cancel out, which is what I wanted. And then I'm left with here negative 4x squared. And then I'll drop down the next term, which is 2x. What do I want to be the next term of my quotient? My answer to my division problem. Okay? 2x. Minus or plus? Okay, so we're going to go with minus 2x because remember what we want is when we multiply that minus 2x times this 2x, we want to get exactly what we have right here because the subtraction process later is going to cause it all to cancel out. Matt? Mm-hmm. You subtract them. I wrote subtraction and then I changed all the signs. I distributed the negative because there's more than one term. Okay, so when I originally wrote this up here, this said minus, and then it said 2x cubed minus x squared. And then I said subtracting is the same thing as adding the opposite of each of the terms. Because my issue is people, when they write minus right here, they only subtract the first one and they don't distribute it to the second one. So I am subtracting, but then I'm doing it a way that I know how to do it with polynomials. Okay? All right, so I get negative 4x squared, and then negative 2x times negative 1 is positive 2x, okay? And like Matt just pointed out, what we're doing with these is we're subtracting all of these. But don't forget that if you're subtracting something with multiple terms, this negative needs to be distributed to all of those terms, right? So negative 4x squared minus negative 4x squared is 0. 2x minus 2x is 0. Another way to look at that, okay? So you can see that each of the terms cancel. You're left with 0. We drop down the next term, which is 4. And our polynomial is not going to go into 4 because this, our divisor, has a higher degree than our remainder right there. Okay, so we're done. So our answer is 2x cubed plus x squared minus 2x with a remainder of 4. Okay, so first be able to recognize that 4 is the remainder. Okay, Cody?
Why did you say that we can't divide any further?
Because this has degree 1. And this has degree 0. So in order for me to make this term match this, I would have to divide by x. So the thing I would pick next would be like 2 over x. And that's not a polynomial with an x in the denominator like that. Raymond? No, but we're not adding 2x to 2x. It was 2x, and when I multiplied this, it was plus 2x, but we're subtracting all of that. So right here, when we distributed, negative 2x times 2x was negative 4x squared, and negative 2x times negative 1 was positive 2x. Okay? But you are not adding these things together. You are subtracting them. Okay? Subtracting that entire polynomial means this subtraction sign applies to the 4x squared as well as the 2x, okay? Which means it's really like adding a positive 4x squared and a negative 2x, so they have all canceled out to be 0. Okay? Is that all right? And then I brought down the 4. So the way that we write this, okay, our final answer is we say our quotient is 2x cubed plus x squared minus 2x. And then because of our remainder, okay, we express it like you guys would express it as a fraction. Okay? So it's positive 4, so I'm going to say plus. My remainder is 4 out of, just looks a little funnier than we're used to, but it comes from the same place. It's out of 2x minus 1. Okay? This is my answer to the division problem. Okay? So the quotient is that entire answer because that's the answer to a division problem. If somebody asked me what the remainder was, my answer to that would be 4. Okay. The division problem works a lot like your normal long division process. You just have to account for the different terms. Okay. Alex? Well, we're going to use these different fractions later on. The reason we don't want you to just write remainder 4 is the same reason you stopped writing it in like the 5th grade. If you say remainder 4 and I don't know what you divided by, it has no meaning. But if you say 4/5, that has a lot more meaning about what's left over, right? Because 4/5 is a lot different than like 4/7 in size, right? So it's more meaningful for us to write it as a fraction, and you're going to see it written more that way as you look through, okay? And it's important to understand how to go from this to this. Okay? Any other questions about that process? Okay, so I'm going to pick a problem from the book, and we're going to race. We're going to see who is better at dividing. Yeah. Okay, you guys ready? I didn't. I just picked it. I didn't practice this last night. I didn't even have time to grade all your stuff, let alone practice this. No. I'll give you guys a head start. Go ahead. I'm not worried. All right. You got that answer? All right. Feeling so good about myself. No. Okay. All right. Okay. Did I get it right, Alex? Okay. You didn't finish? Is that what you're telling me? I'll check the answer. Yeah, I did good. 12 minus 30. Yeah. Okay, so what the heck did I do? I don't know. How many of you would like to know how to do this? All right. So this is called synthetic division. Okay? So it's kind of like fake, right? Like I didn't do the whole process. I just took out some things and kind of worked without the x's. So first of all, since division is an algorithm and you do the same thing over and over again, kind of like the quadratic formula came from completing the square, that like every time you were going to solve a quadratic, you were going to go through the same motions if you completed the square. And so I showed you guys that proof how they got the quadratic formula, right? And they could generalize that because they said, hey, every time you solve a quadratic, you could do this. Therefore, we can give you this formula. It's kind of the same thing because division keeps going through that same like, oh, multiply, write it down, subtract, bring it down, that kind of thing. Then they could come up with a process where they could just look at the numbers and we could do the division without all the x's involved. Now, there's a couple little things. It doesn't work all the time. It works in some situations. It specifically works when you're dividing by a binomial of degree 1. So could I have done this problem if I wanted you to divide by x squared plus 3? No. Binomial of degree 1. Okay? Eric. I checked the answer. It does say minus 35. So look back and see. All right. So what did I do? Look for patterns. How is this even set up? Where did I get these numbers from? What's going on? Dana. Coefficients. Good. Okay. So notice. 1, 0, 3, 1, 4. Good. Okay, so here's the 1, 3, 1, 4. Got it? Okay. All right, if I didn't put the 0 there, especially in synthetic division, I'd be thoroughly confused because notice there's no x's there. So I don't really know what's the x squared, what's the x to the third, all that kind of stuff. So I'm just lining them up in order. If I didn't put the 0 there, I would have combined things together that shouldn't have been combined and all that kind of stuff. Julie. Okay. Yeah, where'd this guy come from? Okay, good. I like that you called it the answer because you're in the right realm of thinking, but let's clear it up a little bit. It's actually the 0 of the divisor. In other words, if you took that factor that you're dividing by and you had set it equal to 0, but this is why you see I'm okay with the fact that Alex identified it as the answer. He was understanding that it's coming from that same place where we had solved stuff before. So that's where that number is coming from. Okay? So we get the setup, right? We take all the digits, okay, coefficients of the thing we're dividing. We find the 0 of the divisor, and we get this row of numbers. What did I do with the numbers? Yeah, so the first thing I did is I set this up. So we've established what that is. I set all these up. We've established that. And then I drew this line. And then I started and I went left to right. So what was the first thing that I did? No, not black magic. Dana. So the first thing I did is I just brought this down. Okay? That's the way the process works, okay? Because they took the pattern of division and they simplified it for you, okay? Every time you're going to drop down the first number. Yep. Raven. Okay, so negative 3 times 1 is negative 3. That's how I got this. What did I do after I filled in this negative 3? I added this column to get this. And once another number showed up below the line, what did I do with that number below the line? Multiplied it by this, and I got 9. And then with the 9, I added up the columns, and I got 12. Okay? 12 times negative 3 gave me negative 36. I added up the column, I got negative 35. And negative 35 times negative 3 is 105. And trust me, if I would have been smarter, I wouldn't have picked a problem with such big numbers. I could have messed up my arithmetic. Okay, 105, and then I add up 4 and 105, and I get 109. So there is the synthetic division process and setup. Now I don't want to race you guys. Okay, so that's the process, the setup, and the work, but you still have to be able to read the work and understand it, okay? So this gets you the answer faster if you can actually read what you did. So I did all of this, and then I wrote this down. So where do you get which pieces? How do you know how to write your answer once you're done and you have this stuff here? Alex. All right, so they're in order of highest power to lowest. How do I know which power to start with? Claire?
I don't understand how, in your original problem,
Right. So what I thought about was putting, just like with the long division, a 0x to the third right there, because I have to have them all go in order, so that's why there's a 0 here.
So then why doesn't it start with
The answer, that's what we're trying to figure out. Why doesn't the answer start with the 4th degree? Julia?
When you're dividing x to the 4th by x, and so to get that, you have to multiply it by x.
Good. All right. You're taking something that was to the 4th power, and you're dividing it by an x to the 1st power, so it's going to decrease that by 1 power, right? So that's how you can know what the highest power is going to be. Since we only do synthetic division with binomials of degree 1, then your answer is always going to be starting at 1 degree less than what your problem started at, right? Because you're only dividing out 1 power of x. Okay? Is that all right with everybody? There's another way to do it. You can do it backwards. Sean?
If the first degree, the second binomial was to the second degree power, would it be x to the square then?
No. Well, logically, yes, but we can't do synthetic division with that because it works a little bit differently. So you have to do long division with that problem. Okay? Yes?
So for the
Uh-huh.
is it always going to be x for all problems?
Not going to be x to the third for all the problems. If this had been x to the third, it would have been x to the second. Okay? All right. So now that we've established that, you can start here. And so you go third power, second power, first power, 0 power of x, and then that makes this guy right here the remainder. Okay? If you can't remember what's power it's going to be, you could work the other way if you want. The last number is always going to be the remainder. So you could work from that way if you wanted. If this is the remainder, then this is the constant. Okay? Then this must be x to the first coefficient, x to the second, x to the third. Julia? Is it possible what? Yes. If it divides evenly, you'll have no remainder. What do we call something that divides evenly into something else? A factor. Okay, like 3 divides 6 evenly, so we say 3 is a factor of 6. So this is going to actually become exceptionally important to recognize when we have a remainder and when we don't have a remainder. Because when we don't have a remainder, not only did we do a division problem, but we have a factor, and maybe that would help us factor further. Okay? Alex. If this column cancels out, you don't have a remainder. Now, if this column had canceled out and made 0, I still multiply 0 times this, put the 0 here, and add up that column. I need to finish the problem. Okay? Yes. Whatever it comes out to be, you're just adding up the column. Okay? All right, so, yeah, it did it again. All right, so why don't we go ahead and practice this. I actually want to look at part B. I know that you guys hate when I skip around stuff, but. Okay. Part B, we're allowed to do synthetic division because it is a binomial of degree 1. Okay? However, it is a little bit different because it has a coefficient of 2. So before you start the synthetic division process, nothing should have a 2. Okay, or any coefficient in front of it. So for example, let me remind you a little bit about fractions. If I want to reduce 4 over 6, it's possible because they can both be divided by 2, and then this gives me this new fraction of 2/3, but only after I divided both the numerator and the denominator by 2, right? Okay. So if I'm looking at this problem in that perspective, before I set up the synthetic division process, first, I need a 0 for my cubic term. My problem is that right here in the denominator, I can't just do the synthetic division process. If I set this equal to 0, I get 1/2. Okay? It's like I had to go through a process of dividing by 2. But if I don't change anything here, I've made a mistake. It's like dividing this denominator by 2, but not dividing the numerator by 2. So when you have a lead coefficient, okay, you want to factor that lead coefficient out. But in order to do that, you have to do that in both the numerator and in the denominator. Okay? So I'm writing this a little bit differently to just help you guys understand why we have to do this. If we want to look at this as x minus or plus a single number without a coefficient, we get it by factoring out the 2. I can only cancel this 2 out completely and then continue my division problem if there's another factor of 2 up here to cancel it out, right? which means when I see that 2 coefficient, I know I must cancel it out. Therefore, I must also factor 2 out of all of the coefficients in the numerator, changing my problem to 2x to the 4th, still 0x cubed, a fraction, which is okay, negative 5/2 x squared, x, and 2. Okay? Then these 2's cancel out, and I'm going to do the division problem with the stuff that's left. Okay? It's perfectly okay. It's just like canceling a factor of 2 out of both 4 and 6 and saying 4 divided by 6, you would get the same thing if you did 2 divided by 3. Okay? Now I can set up synthetic division for this problem. So remember, all of the coefficients of the numerator, okay, the thing that I'm dividing, are going to go across. So 2, 0, negative 5/2, 1, and 2. And what is going to be my number that I am dividing into them or using in this process? Eric? 1/2. So through the process, we drop down the first number. So we have 2, and we multiply. 2 times 1/2 is 1. We add up the column. 0 plus 1, 1. Okay? We have another number below the line. We have more columns to fill, so we keep doing the process. We multiply. We add up the column. Negative 5/2 plus 1/2 is going to be negative 4/2, which is the same thing as negative 2. Okay? Monet? Okay. So negative 2 times 1/2 is going to give me negative 1. I add up the column here. I would get 0. I don't stop because I get 0. I'm not done with my division problem yet. It just makes the next part a little simpler. 0 times 1/2 is going to be 0, leaving me with a remainder of 2. Now I need to be able to look at that, and I need to be able to interpret the answer, okay, or get the answer correct. So what degree is going to be my answer? 3. And I know that because 4th power is being divided by 1st power, giving me the highest power of 3. Okay? So I'm going to have 2x cubed plus 1x squared minus 2x plus 0, which I don't need to write. And then I have my remainder of 2. So currently, that 2 comes from a division problem where I was dividing by x minus 1/2. And then there's one small thing that to make this look a lot nicer and a better mathematical package, you would be asked to do when you did this division problem. They wouldn't leave the remainder looking like this. Any idea what needs to be done to the remainder to kind of make it more proper? Matt? Not multiplying by x minus 1/2. Monet? Not by the reciprocal. Sean? Good. Okay, in both the top and the bottom of the fraction, we're going to multiply by 2. That keeps the fraction the same, right? So why am I choosing to do this? Why is it more proper for me to do this and then leave my answer than it is to leave it like this? Helen? Good, because we have fraction in the denominator, so we have a fraction within a fraction, which it has a meaning. It's just not considered proper to leave it like that. So then we're going to write it as 4 over 2x minus 1 as our remainder, and all this stays the same. Alex, and then Mitch. 2x minus 1 kind of made this x minus 1/2, so it has to do with that. But you don't have to get it back to the original equation. You do have to get it to a place where you don't have fractions within fractions. Mincha?
Or like when you're originally like
Uh-huh.
isn't it negative 1/2?
Why is it 1/2 instead of negative 1/2? Remember, it's what the denominator would equal if you set it equal to 0. So it's like taking your factors and setting it equal to 0. So you get the value that would make the factor equal to 0, not like what you're seeing. Does that make sense? Okay. All right, so that would be how we write our answer with the correct remainder. Is everybody okay with the synthetic division process? Okay, so you can use that anytime you have to divide, unless it specifically asks you to do long division, okay? Or unless we don't have a binomial with degree 1. All right, so notice it says find f of 2. First of all, somebody tell me in your own words, what is someone asking you when they say find f of 2? What does it mean? Jenny? X. Okay, so f is like just the name of the function, and then by putting 2 in the parentheses, they're just telling you 2 is the number you're plugging in. And so you guys are very used to plugging stuff in for x and finding out what you get for y, okay, which is our f value. Okay. Synthetic substitution means do the synthetic division process with 2 as the number that you're plugging in. Okay, so if you're plugging in 2 and you have 2x to the 4th 1x cubed minus 3x squared, no x, and minus 5. So go ahead and do that quickly, and then we'll check that we have the same thing. Okay, so make sure that I did it right. See that you agree. Okay. It's a good little test if you can get through the synthetic division process by yourself. Now, once we have this little bit of work right here, is actually going to answer every question that we have right here. Okay? So the first question it asked is f of 2. Now, you guys say that plugging in 2 is what you get. Go ahead on your paper right now and plug in 2 like you normally would and tell me what you get. Or you can use a calculator. Okay, Matt? 23. Where did 23 show up in our synthetic division process? Okay, so it turns out that this is not only the remainder, it is also the value of the function when you plug in that specific number that's in your little synthetic division box. Okay, so f of 2 is 23. Okay. What is f of x divided by x minus 2? So what do we get when we take that function and we divide it by x minus 2? Matt? Does everybody see where he's getting that from? If x minus 2 is what you're dividing by, you would do synthetic division with 2 in the box. We already did that, right? So we had our answer laid out for us right here. We just had to write it in the form of a polynomial. Okay? What is the remainder when f of x is divided by x minus 2? 23. So we already established this relationship between the fact that the remainder when you divide by this and plug in 2 is the same as the evaluation of the function when you plug in 2. Is x minus 2 a factor of f of x? No. And how do I know that? Good. It has a remainder. Is 2 a 0 of f of x? No. So 2 ways you know that. One, if you plugged 2 in, what should you get if 2 is a 0? 0. Okay? And therefore, x minus 2, if 2 is a 0, x minus 2 should be a factor, like we've been working on the past couple days, right? Is x minus 2 a factor? No, because the remainder is not 0. So there's multiple ways for us to tell. It says no. Is 2 a solution of f of x? What does it mean to be a solution? On the graph where? On the x-axis, right? So to be a solution is to be a 0. Okay? I just asked it differently to make sure that we understand that, right? So, because people can ask it to us multiple ways. Okay? So do we get how this synthetic division process doesn't just give us another way to divide, but if we're talking about binomials, which we have been a lot lately, like all the binomial factors of like a cubic or a quartic or whatever it might be, it can tell us all this stuff with just one little piece of work right here, as long as we can interpret it correctly. Alex? Because when somebody asks you, okay, did you divide 5 into 42? Yes. What was the remainder? You can just say 2. Right? When we write it out as a quotient, the answer to the division problem, we write the remainder as the fraction. But if somebody just asks us, what is the remainder, we usually just give them the value of that. Okay? All right. So go ahead and do the synthetic division process here with -2. I'm going to do it again, and we're going to check and make sure we have the same thing. Part A, sorry, it's a little bit up off the top of my screen. F of -2 is equal to what? 0. Okay? So we established that that number we plug in can be found here. Is -2 a solution of f of x? Yes. Is x plus 2 a factor of f of x? Yes. F of x divided by x plus 2 is equal to what? Somebody new, give me this solution. All right, Julia, go ahead.
X squared minus 3x plus 4.
Good. So x squared minus 3x minus 4. No remainder because of our 0, right? Now we're going to rewrite f of x in factored form. Okay? Now, the fact that you've taken f of x and divided it by x minus 2 and you got this. Think about numerically. You take 6 and you divide it by 3 and you get 2. So that means that 6 could be equal to 3, which you divided into it, times 2, which is what you got as the answer. Okay? So if I know that f of x was divided by this, and I obtained this, Eric, what is our factored form? Okay, so this part factors as x minus 4 and x plus 1. But I need to include x plus 2 if I'm factoring the entire f of x, the original thing I'm given, because I only got this after I divided this part out. So these two things multiplied together would make this, and this times what I divided by originally would give me back my original function. Okay? So what are the other zeros of f of x besides -2? Because you already told me that they're a solution or the 0. 4 and -1. And then can we sketch the graph of this function just using the zeros? Okay. So what is the degree of our function? 3. So our end behavior expectation is what? Opposites. And then its lead coefficient is positive. So exactly what? Down to up or up to down? Down to up. Okay. And I expect to cross through -2, -1, and +4. And here's where the sketch part comes in. I don't know how high those relatives and maximums go or relative minimums, but I know that if it's a cubic with a positive lead coefficient and passes through those zeros, it does something like that. Obviously, the heights of those maximums and minimums could change. Okay. So do you guys see how all this stuff is fitting together? The division is a process, but if it helps you identify a factor, then you have zeros, you know the shape of your graph, you can put all of that information together. Okay? I think you guys don't have to do that part. It's fine. All right, so this is just a word problem using that. Let's just talk about approach so we can make sure that if you come across a word problem in your homework, you have a strategy to try. They give you a polynomial, and they say that it expresses a volume. Okay, so that polynomial is a volume in cubic inches of a box, and the box's length is x plus 5. What are the other two dimensions of the box? So you have this. First of all, you need to be okay with the fact that are you going to get like 8 as an answer? No, you're probably going to get something like x plus 5 as the other dimensions of your box. Okay? How are you going to go about figuring out 2 other dimensions of your box knowing the answer? Factor it out. Okay? So if you want to factor x plus 5 out of x cubed plus 9x squared plus 23x plus 15, what would you have to do? Divide. So you can do long division, you can do synthetic division, and once you divide, you'll have this part removed. You'll have what these other 2 parts would multiply to, and you'll see if you can factor that, because then it will only be a quadratic, right? And then you should be able to factor it. So is that okay for approach to this problem? So that if you see a word problem, you understand the relationship between this polynomial stuff and a real life situation that you might have to solve. Okay? All right. So